Chapter 13 is multiple regression. In this chapter, we take the concepts we covered in chapter 12, simple linear regression, to the next level. In simple linear regression, we had only one independent variable, x, with which we try to predict the values of y. In chapter 13, we're going to do the same thing, that is predicting the value of y, but we're not going to restrict ourselves to just one x variable, that is one independent variable. We have multiple independent variables. So we have these three files related to this chapter. Make sure that you download them all. Print the formulas PDF file and keep it by your side. Follow the lectures along with the PowerPoint file and do all the problems using the Excel shell file. In this chapter, we're going to learn what a multiple regression model is and how to find and interpret regression coefficients, that is the estimates for the slope coefficients, and how to determine which independent variables to include in the model. And then we're going to look at a special kind of independent variable x, which are called categorical independent variables. So far we have assumed that the independent variables will be numeric variables. What if the independent variable is not a numeric variable but a categorical variable, something like majors in business, marketing, management, finance, accounting, that kind of stuff. So how do you incorporate a categorical independent variable in the regression model? So these are the topics that we're going to look at. So first, let's start with the multiple regression model itself. So here you see that there is a very striking resemblance between the model that we saw in chapter 12 and this one. So here we have the dependent variable, and then we have the y-intercept like before. Now earlier we had only one beta sub 1 coefficient. Now we have beta sub 1 through beta sub k. We have x different. We have k different x variables, k different independent variables, and then we have the random error term epsilon. So when we run the regression model, so we're not going to use any formulas this time. We will use the data analysis command in Excel. Then we will develop the coefficients for estimates of the beta value. So instead of beta sub 0, we have an estimated value, which is b sub 0. So in place of beta sub 1, we have b sub 1, the estimated slope coefficients and estimated intercept. Okay. And we will use Excel to develop these. So if you look at a model that has only two independent variables, then we can visualize the multiple regression equation as a three-dimensional plane like this, where you have the slope of x sub 1, which is b sub 1, slope of the second x variable, which will be b sub 2, and this surface is y hat given by this multiple regression equation. Of course, when you have more than two x variables, you cannot visualize this in three dimension. So let's look at an example now. So we have a distributor of frozen dessert pies. They want to evaluate the factors that would influence the demand for our product. So sales, number of units per week, that is our dependent variable, that is our y. And we are now wanting to consider two different independent variables, the price we charge per unit and the advertising budget that we have allocated and we have spent on advertising. And this is given in hundreds of dollars. And the units are very important. So here the y variable is in number, price is in dollars, and advertising is in $100. We have to keep that in mind when we do the interpretation of slope coefficients. So now we have a random sample from 15 weeks. So when we say 15 weeks, and you must keep in mind that this is a time series data. So when you have time series data, autocorrelation could be a factor, could be a problem, the autocorrelation that we discussed in chapter 12. So we have to keep that in mind. But we will visit that in a little bit. But let's first determine the estimates for the coefficients, the intercept and the slope coefficients. So here is the sample data. So this is what our multiple regression equation is going to look like. B sub 0, B sub 1 times price, and B sub 2 times advertising. Okay. So we need to calculate the values for these three coefficients, and what we would do for this is to run Excel multiple regression command from data analysis, and here is the output from Excel. So that's the first part where we have the R squared value and such. We'll come to that in a little bit. We have the ANOVA table second, and then the third part is the coefficients where we have intercept as 306.526 and then minus 24.975 times price, and that makes sense because if price goes up you expect the demand to go down, and that's indicated by the negative sign in the slope coefficient. And advertising coefficient is 74.131. So this is our regression equation. The next step is to interpret these coefficients. What does this minus 24.975 mean? What is plus 74.131 means? So here, as price goes up, and the principle behind the interpretation is same as in chapter 12, where the slope coefficients represent what happens to y when the x changes by 1 unit. So if price goes up by 1 unit, this is what will happen to sales. That is, sales will go down by 24.975, and this sales is in units, so this will also be in units. So if price goes up by $1, then you will sell on the average 24.975 number of pies less. Okay. And here the second slope coefficient is for advertising, and now you must remember that advertising is in hundreds of dollars. So increasing x sub 2 by 1 means increasing advertising by $100. So if the advertising goes up by $100, then this is what will happen to number of units sold. So number of units sold will increase by 74.131 for every $100 increase in advertising. So if you want to make a prediction using this equation, say for price of $5.50 per unit, and if you plan on spending $350 on advertising, what is the sales that you can expect? So plug in the price of 5.5. Now 350 should be converted into 3.5 because advertising in the regression equation is in $100. So $350 will be $3.5. So you should enter 3.5 and not 350. If you enter 350 here, you will get the wrong answer. So 3.5, that gives you your point estimate for prediction of number of units that you will sell. Of course, it would be much better if you can get an interval estimate, but we will come to interval estimate later on. Right now, the point estimate for sales, if the price is set at $5.50 per unit, and if you spend $350 on advertising, and this is our estimate. Now let's look at an example in Excel.